Haji, am I audible? Yashika, Minashi.
Sir, good evening, sir.
Yes, sir.
So, what was the last topic that we did last Monday? What was the last topic?
AC circuit having capacitor.
Okay, we have finished inductor also. Before capacitor, do we have finished inductor?
Yes.
Okay. So we have finished inductor and capacitor also. So let's recall them. Huh? So if you have a circuit having, the first circuit was circuit having resistor only. Huh? So in resistor, the expression for the peak value of current is E naught by R. These are the major topics. I naught is E naught by R. That was the first expression. The second is there is no phase difference between current and EMF. The phase difference between current and EMF is zero. So in phasor diagram also, EMF and current were in same phase. And the important thing is this power factor. Power factor will be 1. So in resistor, peak value of current is E naught by R. Current and EMF are in same phase. Power factor is 1. Then we did after resistor, we have done this thing, inductor. So if you take inductor, then in inductor, current and EMF are not in same phase. The first thing is the expression of peak value of current here is E naught by XL. In resistor, it was E naught by R, but now it's E naught divided by XL. XL is inductive reactance. The phase difference was pi by 2. Current lags EMF by pi by 2. So if equation of EMF is E naught sine omega t, then the equation of current is I naught sine omega t minus pi by 2. So in resistor, EMF and current were in same phase, but when we do inductor, then current lags by EMF by a phase difference of pi by 2. The power factor was 0. And when we did capacitor, so in capacitor, current leads EMF by a phase difference of pi by 2. So when you take capacitor, then current leads EMF by a phase difference of pi by 2. So we have finished everything. Like we have finished this thing also. Low frequency behavior of capacitor at low frequency, DC. We have discussed all these things or not? Minashi, Hishma, Yashika.
Sir.
In the last lecture, when we were doing capacitor, we have finished all these things, power factor, high frequency, low frequency discussions.
Yes, sir.
Okay. Okay, I have opened the wrong file. Okay, so that was the last capacitor. This was the last topic that we did. Huh? We did any numerical on capacitor or not?
Yes, sir.
Okay. So let's do a simple formula based numerical on capacitor. See, the questions that you get in your exam in from AC are from the combination of inductor, capacitor, and resistor. It's very rare that you get questions on only capacitor or only inductor or only resistor. If you get a question on only capacitor or inductor, that's usually a conceptual problem. Otherwise, it's a formula based thing. So let's do a formula based numerical. A capacitor of, let's say, 10 microfarad is connected to an AC supply. AC supply. E is 20 sine 340t. Calculate. First part. Capacitative reactance. Second part, peak value of current. Third part, equation of current. And the fourth part, average power. Please solve it and write your answer in chat room, sir. Solve and start writing your answers in chat room.
So peak value of EMF or current, sir?
Peak value of current. The peak value of EMF is given, it's 20. Yeah. To calculate peak value of current. Okay. Yashika, Hishma, Saifullah, Uneeb, Yashika, Hishma. Okay. Alia. These are formula-based calculations. Okay, let's start it together. Let's solve it together. First part. In the first part, you're supposed to calculate capacitive reactance. What's the formula of capacitive reactance, Hishma?
1 by omega.
1 by omega C. How much is omega, Hishma, in this equation? How much is omega?
314.
Omega is 314. E is E naught sine omega t. Na? So omega is 314. So it's 1 by 314. And how much is C? C is here 10 microfarad. So it's 10 into 10 raised to the power minus 6. So see, 1 by 314 is 0.00031 or 0.0031? 031. Let me divide it. 1 by 314. Where's my calculator? 1 divided by 314. So it's 0.0031. So it's 0.0031. This is 10 into 10 raised power minus 6. So that's 10 raised power minus 5. You take it to the numerator, then this is 10 raised power 5. So this is 0.0031 into 10 raised power 5 is 3, 1, oh, is this 310. Second part. Next, we need peak value of current. Uni, what is the expression for the peak value of current? Uni, formula for calculating peak value of current in a capacitor. Saifullah, how we calculate peak value of current in a capacitor?
So I0 equals to E0 by capacitive reactance.
E0 by capacitive reactance. So how much is E0? E0 is 20. So it's 2 by 31 ampere. Third part, equation of current. So this is the equation of EMF, 20 sine 348. For the equation of current, what should be the equation of current in this circuit, Mehraj? It is a circuit having capacitor only. What should be the equation of current? Akshay, what should be the equation of current in this particular circuit?
Sir, I naught sine omega t.
I naught sine omega t.
No. There is a phase difference between current and EMF. Current and EMF cannot be in same phase. In circuit having capacitor only, current leads. So it will be plus pi by 2, right? If you have a circuit having capacitor only, then current leads EMF by pi by 2. Now substitute the values. How much is I naught? It's 2 by 31. Sine omega. How much is omega? It's 314. T plus pi. Haji, is it clear? It's 2 by 31 sine 314 T plus pi by 2. This is the equation of current now. Fourth part. You need average, average, not current. You were supposed to calculate average power. Anshika, how much is the average power dissipated for this circuit having capacitor only? Anshika,
Sir, I don't remember the formula right now.
just go back to your notes and tell me. Just go back to the circuit having capacitor only and check what is the expression for the average power. Expression for the average power. It's 0, right? Average power in the circuit having capacitor only is 0. This is the expression of average power. Is it clear? Okay.
So in third answer, how do you get A?
I will get in the third
A.
answer. What is A?
A at the last. Is it
Yeah,
ampere?
that's ampere. That's ampere. That's ampere. SI units ampere. Is it clear? That's a formula-based thing. Omar, Akshay, Arpit.
Good evening, sir.
Good evening. Did you get this question? No.
Sir, I'm not even aware of the topic yet, sir, because I left
Okay.
few classes.
Okay. Okay.
Sir, are you doing this in any batch, sir? Because sir, I have such a backlog. How will I cover?
Arpit, I'm not taking online classes this session. I'm taking only this batch. Like I'm not teaching this in this year. That's the only batch that I'm taking. So I can give you recordings. So I'm not taking online classes this year.
So can you share the recordings?
Yes,
The
that
classes?
that I can do. That I can do.
Thank you.
Yes, Ali, average power is always zero. In this type of circuits, average power is always zero. So is it clear? Everyone have written up to here? Hishma, Saifullah, Noha.
Yes, sir.
Yes, sir.
It's okay. Yes, Akshay, recording must have been uploaded. It should have been uploaded. Just check your app. Should be there. Ideally, it should get uploaded in 24 hours, but sometimes they take 36, 48 hours. But within 48 hours, it should get uploaded. Okay, so that was about the capacitor. Now we will do the LCR circuit, like the combination of inductor, capacitor, and resistor, series LCR circuit. We'll start. Okay, so now let's start with the LCR circuit, series LCR circuit. So in series LCR circuit, you have an inductor, you have capacitor, and you have resistor in series. So in previous circuit, when we were deriving the formula for impedance, for reactance, we started with the equation of EMF. But now since it's not a single circuit element, we have three circuit elements in series. So we'll start with the equation of current. The reason is if all elements are connected in series, then same current will pass through them. Current will be same, but yes, voltage will be different. So we'll take current. So all three circuit elements will have same current. This is I naught. Through capacitor also, this is I naught. Through resistor also, this is I naught. Now, I naught means which current? Is this the instantaneous current, RMS current, or the peak current, Minashi? Which current is this?
RMS.
No, I naught. Miraj, what does
Peak
not
value.
mean? Peak value of current. Huh? Then we will calculate voltage across this resistor, voltage across capacitor, and voltage across inductor. What is the expression of voltage, Uneep? How we calculate voltage across resistor?
Sir, V equals to I.
V is equal to IR. If you are calculating peak voltage drop, then we'll take peak current and multiply it with the resistance. If we know the capacitive reactance of the capacitor, then how will you calculate the voltage drop across the capacitor, Mansi?
I'm not sure, sir.
If you have XC, like you have the capacitive reactance, now we calculate the voltage drop across the capacitor. Ishma? You know capacitive reactance. Instead of R, we are using XC. For resistor, we are using I naught R. Instead of R, we have XC. Then what is the expression of voltage across capacitor? Ishma.
I not into XC.
I naught into XC. See, across capacitor, it will be I naught into XC. If you have inductor, instead of capacitive reactance, we use inductive reactance. So it's I naught into XL. So these are the voltages. Voltages across resistor, voltage across inductor, voltage across capacitor. And the next is, now we have to calculate the total voltage drop. Total voltage drop will be voltage drop across resistor, voltage drop across inductor, voltage drop across capacitor. So we have to add up all these three voltages. But to add all these voltages, we can't use parallelogram law. Sorry, we can't add them up algebraically. The reason is voltage is not a scalar. In capacitor, due to the phase difference, voltage will behave like a vector. So let's see the phase difference. All three elements have same current. In inductor, please check. First check in resistor. Are current and voltages in same phase? Just check whether in a circuit having resistor, current and voltages are in same phase or are they in different phases.
Same phase.
Same phase. Current and voltages are in same phase. So that is V naught R. In capacitor, check whether current and voltages are in same phase or there is a phase difference. Derivation doesn't mean that I have to write each and every step. Na? Just check your notes and tell me, is current and voltage in capacitor are in same phase? If
No.
not, then which one is leading? Voltage leads current or voltage lags current? In capacitor, current leads, right?
Yes, sir.
So voltage lags. So in capacitor, voltage lags by current by a phase difference of pi by 2. If we take inductor, so what happens in an inductor? Voltage and current are in same phase or one of them leads?
The voltage leads.
Voltage leads. So voltage leads current by a phase difference of pi by 2. So see, we have to add these three voltages, V naught L, V naught C, and V naught R. We can add these three voltages. See, we can't add them up algebraically. The reason is they are in different phases. So due to this phase difference, these voltages will behave like a vector. So to add these voltages, we have to use vector laws like the parallelogram law. I'm repeating again, voltage across resistor, voltage across inductor, and voltage across capacitor. All these three voltages are not in same phases. They are in different phases. If I compare V naught R and V naught C, what is the phase difference between V naught R and V naught C, Akshay? Akshay, just look at this phasor diagram and tell me V naught R and V naught C, what is the phase difference between them?
90 degree.
90 degree. You can see that V naught voltage across capacitor lags by voltage across resistor. Similarly, if I asked you to compare V naught L and V naught C, what's the phase difference between them? Pi by 2.
180 degree.
180 degree, right? V naught L and V naught C are in opposite direction with respect to each other. Pi, 180 degree. So due to these phase differences, we can't add these voltages algebraically. I can't consider these voltage as a scalar. These voltages behaves like a vector quantity. So we have to add them up using parallelogram law of vector addition. So the next step, we will add them up. We'll calculate the net voltage. But when we add, we will add them up vectorically. We'll use a parallelogram. Just note it down, please. Write it down. Nabil, your exams are over.
Yes, sir.
Can you share your physics paper with me?
Yes, sir. Can you share it after class?
Yes, after the class, just WhatsApp me your paper. And please, all of you, you all have my contact number. Just share your physics paper with me after the class. After the class, please. Your question paper. Just scan the question paper and share with me.
So my whole paper was from EMI, sir.
Your whole paper was?
So from EMI, sir.
Okay, so we have already finished EMI. Can I scroll it now? Akshay, Alia, Anshika.
Yes, sir.
Mansi, it's your first class with me?
No, sir. Second or third.
Second. Okay. You're from which school, Mansi?
ISD.
Okay. Note it down.
So could you just scroll 1 second?
Mhm.
Okay, sir.
Okay, now let's add all these three voltages. We'll add V naught R, V naught L, and V naught C. But to add them up, we'll be using parallelogram law of vector addition. Is it clear up to here? Alia, Noha, Yashika, Nabil.
Yes, sir.
We first calculated the voltage drop across individual elements, and now we'll add them up using parallelogram law. We can't add them up algebraically. Yeah? So to add these voltages, we'll first make the phasor diagram. So let's draw the phasor diagram again. We'll draw it again.
So 1 minute, can you go up?
Yes, yes.
Yes, you can.
So let's draw the phasor diagram. This is the current, which is I naught. This is the phasor diagram of current I naught. If I take voltage across resistor, then what is the phase difference between current and voltage? Is there any phase difference between them across resistor? V naught R and I naught are exactly in same phase. If I take V naught L, then voltage across inductor will lead current. This is V naught L. This is V naught. Voltage across capacitor will lag current. This is V naught C. This angle is 90 degree. This angle is again 90 degree. So we have three voltages, V naught R, V naught L, and V naught C. We have to add them up. To add these three voltages, we'll be using parallelogram law. See, V naught L and V naught C, they're acting in opposite directions. So they get subtract out. So you can either write V naught L minus V naught C, or you can write V naught C minus V naught L. So we will write V naught L minus V naught C if V naught L is greater than VC. So we divide this derivation into two parts. The first part, I'm assuming that V naught L is greater than V naught C, means voltage across inductor is greater than the voltage across capacitor. So V naught L and V naught C, they are in opposite phases. So I just subtract them. So the voltage is V naught L minus V naught C. So first I solve V naught L and V naught C. Now I have to add this V naught L minus V naught C and V naught R. Yashika, what is the angle between V naught L minus V naught C and V naught R? Angle between
Sir,
this
90 degree.
90 degrees. So if you have two vectors which are at 90 degree, what's the formula for resultant? Safula? If you have two vectors A and B and they are at 90 degree, how we calculate resultant?
Yes, it'll be a square plus b square plus 2ab like.
Yeah, 2ab cos 90 would be 0. So it will be just a square plus b square. So that's my vector A and that's my vector B. So the net EMF is V naught L minus V naught C plus V naught R square plus R square. This parallelogram law. Resultant is root over A square plus B square if your voltages are, if your vectors are perpendicular. In the next step, what we can do is we can put the value of V naught L. How much is V naught L? We wrote in the first section of the derivation. How much is V naught L?
I not R.
I naught XL, है ना?
Yes.
V naught C is I naught XC and V naught R is I naught R whole square. So we can take something common from all these three equations. So Anshika, which term you can take common from the both the terms?
Sir, I not.
I naught, not just I naught, it's basically I naught square, right? Because in both the terms there is square. So we can take I naught square common. So it's I naught square XL minus XC square, I naught square R square. I'm taking I naught common from both of them. So when we take I naught square outside the root, it will be I naught only. So it's I naught XL minus XC square plus R square. So we have EMF is I naught into XL minus XC square plus R square. Next, what we can do is we can just take this I naught here. It's E naught by I naught, which is XL minus XC square plus R square. Now we have to identify this term. See, what is, if I use Ohm's law, what is EMF divided by current? It's resistance. If I have a resistor, EMF by current is resistance. If I have a circuit having capacitor, then what is E by I? Akshay? If I have circuit having capacitor only, then what is E by I?
C.
Voltage by current. Sorry?
C.
XC, not C, XC,
Oh.
capacitive reactance. If I have a circuit having inductor only, then what is E by I? Noah?
XL.
XL. So now you have a circuit having combination of inductor, capacitor, and resistor. So this E naught by I naught, which is this term, is known as impedance. And that's impedance. It's root over XL minus XC square plus R square. So that's impedance. The SI unit of impedance is ohm. It's impedance, SI unit is ohm. This term is known as impedance. So impedance basically means the total obstruction offered by the combination of inductor, capacitor, and resistor. When we take resistance, that means obstruction offered by only resistor. When we take capacitive reactance, it's obstruction offered by only capacitor. When we take inductive reactance, it's obstruction offered by only inductor. But when we write impedance, that means obstruction offered by all circuit elements. It's root over XL minus XC square plus R square. The peak value of current can be written as I naught is E naught by Z, where Z is the impedance, E naught is the peak value. I naught is E naught by Z. This is the peak value. So when you have a circuit having resistor only, the I naught was E naught by R. For a circuit having inductor only, I naught was E naught by XL. For a circuit having capacitor only, it was E naught by XC. But when you have a combination of all, then this is E naught by Z. Z is known as the impedance of the circuit. That's the impedance, total obstruction. And geometrically, we can represent, you see, I completed the parallelogram. The diagonal of the parallelogram will represent the peak value E naught. So just by looking at this phasor diagram, Alia, can you say that EMF and current are in same phase or they have a phase difference? This is the EMF and this is the current. Are they in same phase or they have a phase difference? Anshika, are they in same phase or they have a phase difference, the current and EMF?
Sir, they have a phase difference.
Phase difference. So which one is leading? EMF or current? Which
Sir,
one is leading?
EMF is
EMF.
leading.
Very good. EMF is leading. This is phi. Yes, Umar, I'm explaining it again. Phi is the phase difference. EMF leads current by a phase difference of phi. Now you have to calculate this phase difference. So you can write that EMF leads current by phi. So your EMF will lead current by phase difference of phi. So how to calculate the 10 phi here? Okay, Umar is asking how I get this diagram. See, Umar, this is a phasor diagram. So I first take current. The equation of current that I took in the first part of the derivation is I naught sine omega t. So the phase is omega t. So I take current. Then if you look at here, current and voltage across resistor are in same phase. So the same phase I took V naught R. Voltage across the capacitor lags by current by phase difference of pi by 2. So I take this one, V naught C is pi by 2. Then I take this V naught L, which leads current by pi by 2. Then this is V naught. V naught L and V naught C are in opposite phase, so we can subtract them. So I subtract V naught L minus V naught C, and then I add V naught L minus V naught C, V naught R. I'm using the parallelogram law of vector addition that you did in class 11 for vectors. So now adding V naught L minus V naught C and V naught R. So I completed the parallelogram. The diagonal of the parallelogram will represent the net voltage E naught. So this is the calculation. So now I need phi. For phi, what I can do is I can just take this triangle. Let's name this triangle as let's use this. Let's call this as O. Let's call this point as P. Let's call this point as Q. So you have a right angle triangle OPQ. So in OPQ, what is tan phi? Tan phi is perpendicular by base. How much is this tan phi? Can anyone tell me the length of this tan phi? This one, this perpendicular PQ. Which vector here is representing this PQ? Open question.
VL.
No, PQ is represented by which vector?
VL minus VC.
VL minus VC. Good. V naught L minus V naught C. And this is the base. This base is represented by which vector? V naught R. V naught R will represent base. So you can say tan phi is perpendicular divided by base. Perpendicular is V naught L minus V naught C. Base is V naught R. V naught L is I naught XL. V naught C is I naught XC. VR is I naught R. I naught cancel out. So this is again. So you should remember these two expressions for the phase difference. You can get question in terms of voltage, or you can get question in terms of XL, XC, and R also. On the next equation, so this tan phi XL minus XC by R. Now, you know that this here, EMF leads current by a phase difference of phi. So I is I naught sine omega t, E is E naught sine omega t plus phi. So current lags by EMF by phase difference of phi. So you can say either that EMF leads current. If you look at this diagram, then it's very clear. This is current and this is EMF. That EMF leads current by a phase difference of phi. So if equation of current is this, then equation of EMF is E naught sine omega t plus phi. But if you look at current with respect to EMF, then you can say current lags by EMF by phi, right? You can either say that EMF leads, or you can say current lags. So if you take this as the equation of EMF, then the equation of current is I naught sine omega t minus phi. So you should keep both the things in mind. So if you are starting with the equation of current, then EMF is leading. But if you start with the equation of EMF, then current will lag. Then we draw impedance triangle. So impedance triangle is nothing new. Like if you can remember in class 10th, if someone gave you the value of tan theta, he asked you that tan theta is 2/3. And he asks you to calculate the value of sine theta, then what you do? You know tan theta is P by B. You make a right angle triangle, you take perpendicular equal to 2, you take base equal to 3, then you calculate the hypotenuse. Then you can calculate sine phi and cos phi. We are doing the same thing. I'm drawing a right angle triangle using this equation, tan phi is XL minus XC by R. So which one is perpendicular for the triangle? And which one is base? Tell me fast. In XL minus XC by R, which one is perpendicular and which one is base? Tan phi is perpendicular by base. Na? So instead of perpendicular with using XL minus XC, instead of base, we are using R. So I make a right angle triangle, phi. It's perpendicular, which is equal to XL minus XC, and base is equal to R. So I have perpendicular and base, so I can use Pythagoras theorem, root over A square plus B square, P square plus B square. Perpendicular is XL minus XC square and base is R square, which comes out to be equal to the impedance. From this triangle is known as impedance triangle, means base is equal to R, perpendicular is equal to XL minus XC, and the hypotenuse is equal to root over XL minus XC square plus R square, which is said. From this impedance triangle, can we calculate power factor? What is power factor exactly, Minashi? Minashi, what is power factor? Jasola, what is power factor? How we calculate power factor in an AC circuit? इतनी गलत बात है, तुम लोग पावर फैक्टर भूल गए?
Cos pi by 2.
हाँ, cos pi by, not cos pi by 2, cos phi. Cos phi is power factor, na? If phi is equal to pi by 2, then it is equal to pi by 2. Cos power factor is cos phi. So what is cos phi in this right angle triangle, Nabil? What is cos phi in this right angle triangle? How we calculate cos phi here?
Sir, R by Z.
R by Z based upon hypotenuse. So cos phi is R by Z. So this is how we calculate power factor in a series LCR circuit. The circuits that we did earlier, here in those circuits, the power factors have fixed value. If you have resistor, then phi was 0. For inductor and capacitor, phi was pi by 2. But here phi is not fixed. Phi will depends upon the value of resistance, inductance, capacitance. So power factor will be R by Z only. It will not have a fixed value. It will depend upon R and the value of Z. And this is how we calculate average power, ERMS, IRMS, cos phi. Write down these calculations. Note it down. See, this thing is very, very important. Is it clear, Mehraj, Uneeb?
Yes, sir.
Apit, you are not getting it, na?
Yes, sir. It's like difficult.
You have missed starting 15 lectures. After today's lecture, na, just go back to the recording. Then you can connect it easily. Okay, I know you will not be able to understand the physics, but at least try to understand the calculations.
Okay, sir.
First two lectures are very, very easy. Like this is the major chunk. The major part of AC starts from this derivation LCR circuit. First two are easy calculations. But at least try to follow the calculation. You may not be getting what is B naught R, what is XL, what is XC, but at least follow the calculations. You know how to calculate 10 phi, how to calculate hypotenuse. Tell me if you have doubt in any steps. Huh? Uneeb, issues in calculations? Mansi, have you done up to chapter number 6 any somewhere?
Yes, sir.
Have you done up to chapter number 6 in any batch?
No, sir. I stopped during June.
Okay, you stopped during June. And you rejoined last week, no?
No, today.
Today you are joined. What chapter are you doing in your school? Chapter 7?
The same, sir.
Same thing. Okay.
So can you say how you got the vectors?
Sorry? Sorry, Nabil?
Yeah. The vectors, sir. Like VC, VL, VR.
Nabil, I can't get you. Can you please repeat?
Sir, can you say how you got the vectors, sir?
Yes. See, voltage is usually a scalar quantity, right? But due to the phase difference between voltage across resistor, inductor, and capacitor, they follow vector laws of vector addition, vector rules of addition. That's why I'm considering them as vector. Like the first quantity is I naught, current I naught. This is at some. So I draw the phasor diagram using this equation. I is I naught sine omega t. So I take here the peak value is I naught. The phase difference is omega t. Then the voltage across resistor is in same phase, so I take it in the same phase. Inductor is leading by pi by 2, so I take it to be lead by pi by 2, and it's lagging by pi naught c. So are you asking how I am getting this parallelogram, or your question is voltage is not a vector, so I am considering this as a vector quantity?
So kind of both of them, sir.
So the answer of second part is voltage, right, is a scalar quantity, but due to the phase difference, when you add them up, they follow sort of algebra which match with that of parallelogram. So that is the easier way of doing this. Just draw the parallelogram, consider them as vectors, and complete it. The
Yes, sir.
tough way of doing this thing is you write equations. Like for voltage, write equations V naught L sine omega t minus pi by 2, V naught C sine omega t plus pi by 2, and then add them up. Add them up using the trigonometry. You will end up in this expression only. So instead of taking that approach, which is very lengthy, we take the shortcut approach. And is it clear how I wrote this as I naught, why I write V naught here, why I write V naught L here, and why I write V naught C? Is it clear, or should I explain it again?
Sir, I don't know why you put V naught.
Okay.
Like VC, VL, sir. Like capacitor, inductor.
See, I wrote from this expression. When we did the circuit having resistor only, we arrive at this result that I naught and V naught are in same phase. Since they are in same phase, that's why I draw it here. Is it clear now? Voltage across resistor is in same phase as that of current. Why they are in same phase? This we did in previous lectures, so I can't. You have to go through the recording if you miss those lectures. But the fact is, current and voltage across resistor are in same phase. That's why I'm taking it. Okay, Nabil?
Yes, sir.
Can I scroll it now? Yashika? Noah?
Yes, sir.
Everyone have written up to here, na?
Yes, sir.
So Mansi, since you have missed first 6 chapters, and that's a major chunk of your syllabus, so what we'll do, I will we'll do those chapters in revision. First, we'll
Okay.
finish this thing, the syllabus, and then we'll come back to chapter number 1 and chapter number 2. So all of you just keep this thing in mind. Like if you have V naught L, V naught C, and V naught I, and I ask you to calculate the total voltage, then please don't add them up algebraically. They're not scalar quantity. They don't behave like scalars. They behave like vectors. Does anyone of you get your marks of this midterm?
Not yet, sir. I think I'll get tomorrow.
Get tomorrow. Anyone get Saifullah, Minashi, Hishma? Please share your marks in chat room if you get your marks. Akshay, just please write your marks here. Everyone here, if you get your physics marks, please write it here. Also the maximum marks. Huh? I should at least know now how much you are getting. Okay, not bad, Akshay. If your marks are not good, then you should share with me. तो जरूर share करो. Okay, Minashi, your exam is on 18th. Your syllabus is up to 7th, if I remember it correctly. It's up to 7th chapter, na? Saifullah, you got your marks?
Not yet, sir.
Yashika?
So we had our paper today only.
How was it?
Sir, it went well.
It went well. Okay, Minashi, 1, 2, 4, and 6. Current is not in your syllabus.
The for this exam it's not there.
Sir, can you scroll up?
Yes, yes. Scroll up or scroll down? Down, na?
Up, up. Sir.
Up. Okay. Okay, Umar. Fine.
Done, sir.
Umar, just check your chat room. Huh? Hishma, you got your marks?
Yes, sir.
Please write your marks. See, when I अगर बैच में कोई बहुत अच्छा स्कोर करता है then I say okay मेरे स्टूडेंट ने टॉप किया है. If you are not getting good marks, then I am equally responsible. Just at least I should know na how much you are getting.
But sir, our highest wasn't that high in our school, sir.
It's okay. But still there is scope. Miraj, Hishma, I'm waiting. Please write your marks. Noha, you got your marks?
So my exam is on 17th October.
Absolutely. It's okay. Alia? Okay. Yes. I know. So when you have the next exam, Ali? December. That would be your pre-board, no? It's okay. Miraj, yours?
I didn't get my marks yet, sir, but the teacher told us the highest of her.
What's school name? What's your school name?
The
Raj?
Mother's International School.
Mothers International. That one which is near ID Delhi.
Yes, sir.
Sir, for I equals to I0 sine omega t, is it minus pi 5 or plus 5?
Here it's plus 5. EMF leads current, and here it's minus 5. Omega t minus 5. This is minus 5. Miraj, how was your exam today? Sorry, not Miraj. Nabil. Nabil Ahmed, how was your exam? Can I scroll it?
No, 1 minute.
Hmm. Okay, now let's do the second case. In the first case, we consider that V naught L is greater than V naught C, but in the second case, we will take V naught C is greater than V naught L. So can you expect what changes in the calculations would be right from the phasor diagram? Let's discuss what could be the changes in the phasor diagram if I'm saying that V naught C is greater than V naught L. Yashika?
So can you repeat?
Yes, I'm saying if I take the another case in which V naught C is greater than V naught L, then what changes will be there in the phasor diagram?
So the resultant would be in the direction of V naught C.
Good.
Oh.
So everyone is, yes, right. Everyone is getting that if V naught C is greater than V naught L, then we're taking V naught C minus V naught L, right? V naught C minus V naught L. So
Yes,
the
sir.
and the difference will be instead of V naught L minus V naught C, we'll be taking V naught C minus V naught L. Instead of this, we'll just switch the thing. So the difference will be, oh yes. So it's V naught C minus V naught L. We are adding V naught C minus V naught L is V naught R. So we just finished the completed the parallelogram. The diagonal of the parallelogram will give the net voltage E naught. And you can see from here that I naught and E naught are not in same phase. E naught lags by I naught by phase difference of phi. So there will be two difference. One is here V naught X instead of XL minus XL, we're getting XC minus XL plus R square. I naught will be E naught by Z as ever. Phase difference will be instead of XL minus XC, you will take XC minus XL. And now here your voltage is not leading, your voltage lags by current. So the equation of current is I naught sine omega t, then for voltage you will get minus phi. But if I start with the equation of EMF, E naught sine omega t, Hishma, can you predict the equation of current? See this phasor diagram. If I write the equation of EMF as E naught sine omega t, what should be the equation of current, Hishma?
I not sin omega.
Sorry,
I not sin omega t.
just omega t, or you have to add something because this I naught and E naught does not seems in the same phase.
Omega t plus phi.
Plus phi. Very good. So I naught omega t plus phi. So this is the equation of current. Clear, Akshay?
Yes, sir.
Nabil, are you in class? Nabil Ahmed? And the formula for the phase constant cos phi power factor will not change, will be R by Z only. Average power will not change, it will be E RMS I RMS into cos phi. So that is the series LCR circuit. Just note it down from here. Just repeat all these calculations. The only difference will be instead of XL minus XL, we're getting XC minus XL. And lead and lag will change. Just note it down. Can I scroll it?
Yes, sir.
Yes or no?
Sir, let me
Sir, can you scroll up?
Yes.
सर ये आपने लेफ्ट और राइट में अलग क्यों लिखा?
In the left side, I'm assuming that current is I naught sine omega t. So if you're taking current, then EMF will lag. But if you consider your EMF as sine omega t, then your current will lead. See, this is a phasor diagram. With respect to current, EMF lags. But with respect to EMF, current leads. So that depends what
सर तो
equation.
सेम ही होगा आंसर तो.
अच्छा, अगर A है और ये B है, मैं इसको ऐसे कह सकता हूँ ना, B A से आगे या A B से पीछे. So I'm using the same terminology. माइनस प्लस का चेंज नहीं आएगा। देखो करंट इज आई नॉट साइन ओमेगा टी, ईएमएफ लैग कर रहा है। अगर तुम ईएमएफ को ई नॉट साइन ओमेगा टी ले लो तो करंट के साथ क्या होगा? करंट अब भी लैग करेगा, लीड करने लगेगा। नहीं आया नहीं।
नहीं सर, सर एक बार फिर से बोलना।
करंट है आई नॉट साइन ओमेगा टी। यहाँ देखो यार, मैंने करंट से स्टार्ट किया, मैं कहता हूँ ईएमएफ क्या कर रहा है? लीड कर रहा है, लैग कर रहा है?
लैग कर।
तो करंट इज आई नॉट साइन ओमेगा टी तो लैग कर रहा है। बट अगर मैं कहता हूँ ईएमएफ इज ई नॉट साइन ओमेगा टी तो करंट के साथ क्या होगा?
करंट तो अभी भी लीड करेगा ना।
लीड करेगा, लैग तो नहीं करेगा। तो अगर
नहीं
ईएमएफ की इक्वेशन ई नॉट साइन ओमेगा टी है, देन व्हाट शुड बी द इक्वेशन ऑफ करंट?
सर, आई नॉट साइन ओमेगा टी प्लस।
मेरी समझ गए?
तो आंसर फिर सेम ही आएगा ना।
बात एक ही है, लेकिन लिखने का तरीका दिख रहा है अलग अलग है।
यस।
कहाँ से? Nabil Ahmed, is it clear?
Yes, sir. Sir, how do you know which one is leading?
By the phasor diagram. By this diagram, I know that current is leading and EMF lags.
Sir, if EMF was leading means it will be above the current vector.
It will be above the current, like it was in the previous section.
Yes, sir.
Now let's do one small question on LCR circuit. Then we will do some RLRC circuits. So the question says, an inductor having L equal to, let's say, 10 millihenry, capacitor C is equal to some 100 microfarad, and resistor having R is equal to 10 ohm are connected in series with this supply. E is equal to 20 sine 340. Calculate first part. Impedance. Second part. Peak value of current. Third part. Phase difference. Fourth part. Equation of current. Fifth part. Average power. Note down the question and please keep start doing your calculations and write your answer in chat. You can discuss with me if you have any doubts in any part. This is it. First, convert this millihenry to Henry, and capacitor, convert this micron to cap. Actually, it's 10 millihenry. 10 millihenry is the inductor. So just remove milli, remove micro from here. And this is your omega 314. And remember, 1 by 314 is 0.0031. This will help your calculations. Do it. First, write the answer of impedance. Huh? How much is it?
Sir, how we will know that which case should we use for impedance?
Because that you will decide now. You will calculate XL and you will calculate XC. So if XL is greater than XC, then you can decide the case. Right?
Okay, sir.
So how do we calculate XC?
Sorry?
How do we calculate XC and XL?
Okay. XL is omega L. XL is omega L. And XC is 1 by omega C. Fine. And this is the standard equation of EMF. EMF is E naught sine. So from here, if you compare, you can get the value of omega. And your L is 10 milli. Your C is just don't forget to remove milli and micro. Please write the answer of first part if you did. No one get the answer for the first part? Okay, Saifullah. Okay, Alia got some answer. Okay. See, let's first calculate XL, then we decide who is correct. So XL is omega L. How much is omega? It's 314. Into L. L is 10 millihenry. So that's 10 into 10 raised power minus 3. So it comes out to be 10 raised power minus 2, 3.14. That's XL. So when we calculate XC, it's 1 by omega C. Omega is 314. And C is 100 microfarad. It's 100 into 10 raised power minus 6. So it's 0.0031 into 10 raised power. It's something around 31. And your resistance is 10 ohm. So when we calculate impedance, so it's very clear that XC is greater than XLR. So it will be XC minus XL whole square plus R square. So it's 31 minus 3.14 square plus 10 square. 31 minus 3.14. 31 minus 3. 776 plus 100, it's 886. 886 ohm. So when we take root of 886 ohm, so 886, 600. It's 29.76. So Akshay was correct, and also Saifullah, Alia, and Noha. Minashi, you two are making sense. Is it clear? Mr. Paul?
Yes, sir.
सर मेरा 30.3 आ रहा है.
हाँ तो ठीक है, इतना तो error आता है. So that's 29.76 ohm. Yes, Akshay. Now solve the second part, peak value of current I naught. Okay, Minashi, yes, it seems correct. Yes, Minashi is correct. What about others? Yes, Ali, it's correct. Hishma?
Sir, why is impedance only in ohms?
Sorry?
The impedance, like for calculating, we will take Henry, we will take this farad also, right? Why is the final answer only in ohms?
Final answer is in ohms.
Yes, sir.
because both XC and XL are also in ohm. XC and XR, the unit of both is ohm also.
So it won't be
Sorry.
or in sir XC and XL won't be in Faraday or in Henry.
No. L will be in Faraday, na? But when you take omega L, it will be ohm. C is in Farad, but when you take 1 by omega C, it's ohm.
Yes, sir.
XC, XL, and R all have same units. Both are all are resistance. So after first part, if we do second part, the peak value of current we need. Peak value of current is peak value of EMF divided by impedance. The peak value of EMF is 20. Impedance is 29.76. So when you do it, it's 0.67. After current, try to calculate this phase difference and the equation of current. Do it. Calculate phase difference and then equation of current. Tan phi. Phase difference. The third part is phase difference. Tan phi. See, when we calculate tan phi will comes out to be XC minus XL divided by R. XC is this term 31. XL is 3.14 divided by R. R is the resistance. Resistance is 10 ohm. So 31 minus 3.14. 31 minus 3.14 is 27.86 and it's 2.78. It's 2.78. So phi comes out to be tan inverse 2.78. Fourth part. After tan phi, the next is the equation of current. When you take equation of current, it comes out to be I naught sine omega t. So when XC is greater than XL, the current will lead omega t plus phi. So the equation of current will be 0.67 sine omega is 314 t plus phi, where phi is this. This is the value. Now try to calculate average power. Good. Just note it down and calculate average power. Write your answer in chat. No need. That depends upon XL and XC. If XL is greater than XC, then current will lag. See the first part of the calculation. When V naught L was greater than V naught C, then your current lags. But when X, now it's leading. There are two cases. In one case, current will lag. In another case, current will lead. Calculate average power now. Average power. See, average power is ERMS, IRMS into cos phi. So first write ERMS as E naught by root 2. Write IRMS as I naught by root 2. And cos phi you can write as R by Z. Put all values. The value of ERMS, E naught. 2.78. Huh? Earlier it should be 2.78. Huh? $2.278. Is it average power, Alia? Okay. See, average power is just ERMS multiplied by IRMS into cos phi. You can write ERMS as, okay, Akshay, let me check. ERMS is E naught by root 2. IRMS is also I naught by root 2. Cos phi is just R by Z now. So if I substitute all values, E naught is 20. I naught is this, I naught is 0.67. Root 2 into root 2 is 2. R is the resistance. Resistance is, how much is resistance? 10. Divided by Z. Z is 0. No, sorry. 29.76. So this is 10. 10 into 1000. So it's 67. Divided by 29.76. So 67 by 29.76 is 67.
So it has 30.
29.7. Just 1 second. 67 divided by 29.03. No.
So 2.58.
Yes, it's 2.25. It's around 2.25 watt. This is the unit of average power.
Or is it okay if we just take it as 30 in the denominator?
If you take denominator as 30,
Yes, sir.
yes, it's okay. So that is LCR circuit. We will come again to the numericals of LCR circuit. But in LCR circuit, there is one condition of resonance. We'll get major questions on LCR circuit with the resonance condition. We'll come back to the circuit, but once we did the resonance condition. If you look NCRT, the almost all the questions in NCRT on LCR circuit are based on the resonance conditions. We'll do resonance, then we'll come back to numericals of the LCR circuit. Okay, so let's stop AC here. Let's start the revision of chapter number 4. That J needs stuff. So we have finished current electricity up to the last lecture. So now we will be starting.
Sir, can you show the third part?
Sorry.
Can you show the third part?
Yes, yes.
Done, sir.
Okay, so let's stop here. We'll start with the revision of magnetics. Current electricity will do magnetics. Now, for magnetics particularly, if we compare the syllabus of JEE and NCRT, then all topics exactly match. There is not even a single topic which is in the syllabus of JEE and not in CBSE. That cyclotron is removed from both like JEE and it. You won't get question in JEE also. There's only one small application of Biot-Savart's law, which is basically a derivation, which is in JEE syllabus but not in NCRT. Else than that, the whole syllabus is same. But yes, the standard of questions is very different. So let's come to that part. I have that JEE book with me. Okay. So we'll concentrate on the questions only. Yeah. There's one topic, magnetic field due to a long wire having some semicircular cross section. But else than that topic, all topics which are in CBSE match with that of JEE. The only difference is in the level of questions. Okay. So we will start from the force on a charged particle in magnetic field. See, first we'll do force on charged particle and then we will do Biot-Savart's law and Ampere-Savart's law. Let's start with the first question. So you have an electron, it's moving along positive x direction with a velocity of 6 into 10 raised power 6 meter per second. It has a region of uniform magnetic field of 300 volt per centimeter pointing along y direction. The magnitude and direction of the magnetic field set up in this region such that the electrons kept moving along the x direction will be. So if you look at this question very carefully, just note this question, then we'll start the calculations. Please note down this question, then we'll start the calculations.
So which question we are doing?
First. Please note down the question, then we'll start calculations. When I ask you to note down, I mean just read this question thoroughly. When you write, just try to identify what are the given terms and what is the thing which is asking you to calculate. Meanwhile, which theory topic you will be using in this numerical should come into your mind. If you don't understand a question properly, you can't answer it. Even after I write the solutions here, you won't understand if you don't understand the question properly. So invest good amount of time in understanding question.
Should we convert 300 volt per centimeter into volt per meter?
Yes, we'll do it. We'll convert it in voltmeter. Everyone have written this? Yes, Oni, that's the logic. It's basically the question is on. Do you remember any device on which this question is based? Does anyone can name the device on which this question is based?
Velocity selector.
Yeah, this is based on velocity selector. Very good. So you have a charge particle Q. The question says it's moving with some constant velocity V. The velocity is this. Electric field is along y-axis. The value of electric field is this. He's asking about the magnitude and direction of magnetic field. You know that if it is a positively, no, it's not positively charged particle, it's a negatively charged particle. So this negatively charged particle will experience the magnetic force in the downwards direction, electric force in the downwards direction. So if you want this particle to pass with a fixed velocity, that means the magnetic force should act in upwards direction. So for the equilibrium of this particle, the magnetic force and electric force should balance each other. Magnetic force should be equal to the electric force. Magnetic
Q
force
is equal to V is equal to
QEV sine 90, and electric force is, you can write it's QE. The Q will cancel with this Q. You can write that your B is E by V only. So how much is E? E is 300, right? Volt, but 300 volt per centimeter. So it's 300 divided by centimeter, which is 10 raised power minus 2. Divided by V, V is 6 into 10 raised power 6. So this comes out to be 6 5s are 30, 0. So it's 5 into 10 raised per minus 2 and 6 it's 4. If you take it to the numerator, it comes out to be minus 4. So it's 5 into 10 raised to the power minus 4. Am I right? Or it's minus 3?
I think it's minus 2 I got.
6 into 10 raised power 6. 6 5s are 30, 50. So it's 6 and minus 2, it's 4. Minus 3, right? Should be minus 3, that's 50. So this is the magnitude. See, both these two options are same. You have to decide the direction of magnetic field also. So your two options, either Z or minus Z. So to decide whether it's Z or minus Z, use hit and trial method. First, assume that your magnetic field is outwards. If your magnetic field is outwards and you apply right hand thumb rule, you place your fingers along velocity and curl it towards magnetic field. Some is going downwards, but the downward is for a positively charged particle. For negatively charged particle, it will be upwards. So your force is upwards. If magnetic field is outwards. So the correct answer is this. So if you can remember from the class notes, before this velocity selector, we have discussed this numerical. The very common question that can come in your board's exams. Is it clear? Yashika, Unib?
I think let's see how to do the right hand thumb rule again.
Yes. Just place your finger along the velocity and your magnetic field is outwards. So curl it outwards. Your thumb is going downwards. This downwards is for a positively charged particle. Now 6 electron is a negatively charged particle. So just reverse it. It should be upwards. Okay, start doing this question number 2. Meanwhile, I'm repeating it again. See, the charged particle is moving with a constant velocity. That means the net force on the charged particle is 0. Then it is placed in a region having both electric and magnetic field. So electric field experience a force on the charged particle in the direction of field if it is positive. But if your charged particle is negative, then direction of force is opposite to that of field. So electric force is downwards. If you want this charged particle to move with a constant velocity, then it should experience no net force. That's only possible if magnetic force is acting in upwards direction. So in equilibrium, FP will be equal to FE. FP is QEB sine 90. FE is QE. So you can get the value of P from it. And for the direction, it's either positive Z or negative Z. We apply some hit and trial method. We assume that your magnetic field is outwards. We place a finger in the direction of velocity and curl it's outwards. Thumb is downwards for a positively charged particle. For a negatively charged particle, it will be upwards. So you need force in the upwards direction. That means your field is along positive side. Now write this question. Write down question number 2. This is easy. Akshay, can you decide this question is based on which concept? No.
No.
Yoshika, can you decide which this is based on which concept? Minashi? Saifullah, can you decide which concept you'll be using here? Alia?
So dipole of magnetic field of an electron.
The path of charged particle in magnetic field. We did after the magnetic Lorentz force, we did 4 cases. There was one case when charged particle was moving perpendicular to magnetic field, then the path was circular. R is mv by qb. So this is the plate as a YZ plane. This is your charged particle. It's coming here. It's coming here with some velocity v. The separation between the charged particle and its t. So you know that the magnetic field is along z-axis. Magnetic field is perpendicular to it. So due to this perpendicular magnetic field, the path of the charged particle will be circular. It will not hit the plate only if the radius is less than or equal to d. So when you take radius, it's mv by qv is less than or equal to d. So you can calculate a minimum value of v. So you can say that v is less than or equal to dqb by m. dqb by m, dqb by m, dqb by m. Easy concept. Is it clear? Nashi,
Can you
Saifullah?
show the question?
Yes. This one. Ajay, written? See, not all questions in mains are very tough. So very balanced paper. Few are easy, then a moderate one. Then you have some really tough questions. The first attempt of mains will be in Feb, the second most probably in January, and the second will be in April. So the usual strategy is for the first attempt, prepare your class 12 syllabus very well. For the second attempt, you will have a gap of 1.5 months. During that 1.5 months, you can revise your class 11, 12. So the second attempt, you'll be fully prepared for 11th and 12th.
सर इस बार शायद जनवरी में नहीं
हाँ शायद नहीं होगा क्योंकि फरवरी में बोर्ड्स एग्जाम्स है बट लेट्स जब तक नहीं आता है एनटीए का नोटिफिकेशन लेट्स टेक इन दैट वे ओनली
सर कौन सा क्वेश्चन करना है
सेकंड हो गया बस अभी तो यहीं छोड़ेंगे क्लास खत्म हो गई बट प्लीज टेक सम प्रीवियस ईयर्स बुक और उसको करना शुरू कर दो अब जितना ज्यादा आप प्रैक्टिस करोगे उतना मैं तो कुछ ही क्वेश्चंस करा सकता हूँ बट व्हेन यू प्रैक्टिस क्वेश्चंस फ्रॉम द प्रीवियस ईयर्स देन यू विल रियलाइज कि ओके बहुत कुछ है व्हिच मैच विद द सीबीएसई व्हिच मैच विद एनसीईआरटी ऐसा नहीं कि कुछ नया है बिल्कुल बट ऑब्वियसली आप कितना अच्छा करोगे दैट डिपेंड्स कि आप कितनी प्रैक्टिस कर रहे हो यूजुअली आई सजेस्ट कि एटलीस्ट लास्ट 8 years 6 7 8 years के आप PYQ कर दो okay so let's stop here in the next class we'll do more questions
थैंक यू
okay Adil Omar I'll explain it in the next class okay what are the basically in mains you can give 2 attempts first attempt is in January and a second is in April the best of 2 will be counted in your final your rank the best of these two
Thank you, sir.
okay
Thank you, sir.